n is a positive integer, and the question is when n minus 1 into n plus 1 is divided by 24, what is the remainder? First statement, it says n is not divisible by 2. That simply means n is an odd number. So if n is an odd number, n minus 1 and n plus 1 both are even numbers, and if we see carefully, these are consecutive even numbers. When I say consecutive even numbers, for example, n is equal to 3, let's say. So it means n minus 1 into n plus 1 would be 2 into 4. Okay. Similarly, we can have combinations like 2 into 4, 4 into 6, or 6 into 8, those kind of combinations. Now, if we write consecutive even integers, we will notice that every alternate even integer is a multiple of 4. Okay. So, out of these two numbers, one is a multiple of 4, and obviously both are even numbers. So, one is a multiple of 2 also. This whole thing is a multiple of 8. So, that means first statement simply tells us that this number n minus 1 into n plus 1 is a multiple of 8. It is divisible by 8. Now, we can have 8, we can have 16, we can have 24. So, when these numbers are divided by 24, we get different remainders. So, first statement is not sufficient. Now, let us come to the second statement. It says n is not divisible by 3. So, it could be like 2, 4, 5, 7, 8, 10, 11. Now, if we take any of these numbers, for example, 2 will make this as 1 into 3. If you take n as 4, will make 3 into 5. If I take 5, will make 4 into 6, and so on. Now, if you see carefully, one of these numbers is a multiple of 6 always. So, this whole term n minus 1 into n plus 1 will be a multiple of 3 always. So, multiples of 3 can be 3, can be 6, it can be 9, it can be 12, and so forth. And again, if we see, if we divide all these numbers by 24, we will get different remainders. So, again, second statement also is not sufficient. If I combine the two, first statement says it is a multiple of 8, second statement says it is a multiple of 3. So, the whole thing, if we take the two statements together, has to be a multiple of 24, and the remainder would be 0 always. So, C is our answer. Combination is sufficient.